So this is the unit activity for Unit 7. You should have already watched the video for Unit 7. And I'm going to go through the unit activity to give you an idea of what's going on here. So what we've got is, in the unit activity, a standard normal density curve here, and then another curve, which is a dashed line. So the first question involves really the solid line, because the solid line is the standard normal density curve. The standard normal density curve is the solid one. It represents a normal distribution with a mean of 0 and a standard deviation of +1 and -1, so standard deviation of 1. And there's a vertical line at mu equals 0, which marks the first line of symmetry. So question is, between what two values on the horizontal axis would you expect nearly all the data from the standard normal distribution curve to fall? So standard normal distribution curve is this one, and that's the solid line. Well, if you look and follow the line down, on the left-hand side at the low end, it's going past -3, maybe to there, -3.5, and over on the side where standard deviations are greater than 0, 1, 2, 3, a little bit more, I don't know, 3.5. Just visually looking at it, -3.5 to +3.5 is going to be where all the data falls. You could even go -3 to +3. Nearly all the data falls between standard deviation -3.5 and standard deviation +3.5. Well, next question could be, between what two values would you expect the nearly all of the lower 50% of standard normal data to fall? Looking at the curve, this is our standard normal curve. Nearly 50% of the data is going to fall in this region, which is between -3.5 or -3 and 0. So that's kind of like what we're looking at, that shaded portion of the curve. So nearly all of the data in the lower 50% for the standard curve falls between standard deviation -3.5 and standard deviation 0. For the next question, you've got in figure 7.10, there are two curves, so the normal density curve and a standard normal density curve. Standard normal density curve has a very specific shape. The normal density curve is the one with the dashed line. The question is, for the curve with the dashed line, is it bigger or smaller than 1? Okay, so let's just take a look. All right, so you can compare any 2 points on these curves, but let's just, go here. So the standard normal density curve, the solid line, is steeper, and it's more grouped around the center. And so it has a smaller standard deviation than the broader, flatter dashed curve. The dashed curve has a standard deviation greater than 1 because it's squatter and the data is not as tightly grouped around the mean. So now I'm asked to estimate the standard deviation for the dashed curve in figure 7.1. And you identify this because it's going to be the value on the horizontal axis where the curve switches from bending downwards to bending upwards. I'm going to show you a way of doing this. So what I'm going to do is I'm going to take a ruler and I'm going to draw a straight line like so on the curve, and then I am going to identify the 2 points where the straight line is just leaving the curved portion of the dashed line. I identify the midpoint of that segment, and then I draw a dashed line down to the axis, and I see that the standard deviation is about 1.5. An expanded view of what I did. So the mean of this dashed curve is going to be around 2. All right, so now between what two values would we expect nearly all the data from the normal distribution shown by the dashed curve to fall? And let's just take a look at the curve. Okay, here's the dashed curve. So basically, I don't know, -1 out to 5. So almost all the data for the dashed curve is going to fall between a standard deviation of -1 and +5. So we'd expect nearly all the data to fall between -1 and +5, standard deviation -1 and standard deviation +5. Well, looking at the curve, well, here's the mean. The mean's at 2. So that's 3 standard deviations, 1, 2, 3 standard deviations below the mean, and 1, 2, 3 standard deviations above the mean. So now we're going to look at some standard normal deviation curves, and these curves have slightly different shapes and they have different means. So our task is to do some matching. So here are some sets of information that we have to match with the curves. So notice that set number 1 has a mean of 4. Set number 3 has a mean of 4, but different standard deviations. So let's see if we can pick those off first from our graphs here. So I would say that curve C and curve D both have means of 4. However, the standard deviation for curve C, just eyeballing the inflection point here, it looks like curve C has a standard deviation of 0.5 because at the inflection point, the standard deviation is 4.5, which is 0.5 up from the mean. In curve D, the standard deviation at the inflection point is 5, which is 1 unit up from the mean of 4. So curve D has a mean of 4 and a standard deviation of 1. Curve C has a mean of 4 and a standard deviation of 0.5. So I would say the curve A, well, that curve A has got a standard deviation of, curve A has a mean of 15, and it looks like the standard deviation is 3, because on our axis, the inflection point is at 18. The difference between 18 and 15 is 3 units. That's a 3-unit difference there. And so for curve A, the mean is 15. Standard deviation is 3. For curve B, the mean is 5. And at the inflection point, the we've got a standard deviation of 2 because on the scale on the bottom, we're at 7 standard deviation units, but you got to realize the mean isn't at 0, the mean's at 5. So the difference between 7 and 5 is 2. So the standard deviation for curve B is 2. And so then labeling the different sets of information, you can see how curve D is set 1, etc. I'll give you a couple of tips on a couple of the exercises. So here's exercise 1. And what we need to do is identify the mean and the standard deviation. Okay, so with this curve, height of 4-year-old boys, the mean is 40 inches. So, well, here's 40 then on our scale. And to find a standard deviation, it's a standard normal curve. What I'm going to do is I drew my line, which is parallel, or actually goes over top of the curve over its straightest portion. I identify the two locations where the curve is just pulling away from this straight line, and I found the midpoint of that resulting section. And then what I'm going to do is I'm just going to come down and I'm going to say, okay, right about here, that's going to be one standard deviation. So a standard deviation is 1.5. So the value here would be 41.5 inches at that point there. Now, because it's totally symmetrical, I'm going to actually, sorry about that, because it's totally symmetrical, I'm going to just draw a line parallel to the axis over to what I identified as my first standard deviation point. And then I'm going to come down again, locate the lower standard, the minus 1.5 standard deviation. So 40 minus 1.5 is 38.5. That point there is 38.5. And that's question 1. So once again, you're going to use the polished silicone wafers to get some data. This is the thickness of polished silicone wafers. Looking at sample set 1, you need to make a histogram and sort of sketch the shape of that histogram. Watch what I'm going to do. I'm going to use the plotter, histogram plotter, which is in your Moodle course here, the histogram generator. And what I'm going to then do is I'm going to, once I've got the generator operational, I'm going to copy the data in column by column, copy and paste it into the generator. So what you will what it'll look like in the end, you'll have a column of data in your histogram generator, and then you would generate the histogram, generate a histogram which looks like this. I used the editing function in the histogram generator to put my starting value at 0.35 and have my bin width of 0.5. Notice I can draw quite a symmetrical curve over top of this histogram. So I've taken all of set 2 and I've imported that into the histogram generator. And now I'm just going to show you how I changed the bin value as well as the starting value. Notice the starting value right now is 0.36. So here's what I'm going to do. I'm just going to edit it. So I'm going to have my lowest class value is 0.35, and I'm going to specify the range. Class range is going to be 0.05. Okay, edit histogram. And there's my histogram. And so now when I look at this histogram, it's not symmetrical. So when I try to sort of sketch its shape, it's going to do this kind of thing. So it's skewed. It's a non-symmetrical histogram. The important thing to remember when you're taking data from a table like this and importing it into something like the histogram tool or Excel, you have to copy the data one column at a time. So that's an example to get you started with the exercises and the follow-up questions for Unit 7.